In calculus, we are interested in the slope of tangent, and which is a limiting value of the slope of secant. In order to find the limit, we need to know when the limit exists. If a limit doesn't exist, then the slope of tangent may not be able to find. So in this lesson, we are going to discuss when the limit of a general function exists or not, and it is related to the left and right limits. In order to find the limit algebraically, you can use the following techniques. So if the denominator of function is not there, so if the function exists, function value exists at that point, then the limit exists. We just do the direct substitution. And sometimes we need to do factoring to get rid of the denominator equals 0. And the rationalizing, we have used it for solving the slope of tangent. And one-sided limits, that is left side, right side. If the limit is hard to find at a certain point, we could do from the right side and left side to see if the value of the function exists or not. And the change of variable, if the expression is very complicated, we could change the variable, introduce a new variable to do the simplification. And also from the graph, we could find the limit. This is what we are going to focus on, is when the limit exists in this lesson. So the limit for a general function, we could write it as this way and read it as the limit of function f at x when x approaches a equals L. This means the value of f at x could be get closer to a value L when x is get closer to a but not equal to a. And when does it exist is from the right side approaches a value. If that function value exists, then we said that is right hand limit. Or we need to check from the left side, the x value is smaller than a, and see if the value of the function exists. Then that value, if right side, left side, they equal to the same number, we say the limit exists and equals to the left side, right side limit equals L. So now we are going to see using the direct substitution or other techniques to find the left side, right side limit and to see if the limit exists. So first example is the limit of, this is xy notation, 3x squared plus 4x minus 1 when x approaches 2. We are looking for the limit of this one, and you see we don't have the denominator. By default is 1, so it's not 0. Then we are going to do just the direct substitution. Direct substitution means we just sub in x equals 2 to the function, so 3 bracket 2 squared plus 4 times 2 minus 1. Then once we sub in the value of x, we get rid of the limiting value sign. So it's not limiting value, it is equal to. Then we do the BADMAS exponent first, 3 times 4 plus, this is multiplication, so before the adding subtracting, we do the multiplication. So 3 times 4 is 12 plus 8 minus 1. For adding subtracting, we do it from left to right, equals 19. So this is a direct substitution. If the function is defined at the value for the x approaches, then we could just substitute that x value to the function, then we have the final answer. Example 2, you will see we have an expression that is more complicated, and when x equals 2, we do the direct substitution, it will have the denominator equal 0, so we couldn't do that. We have to manipulate with this expression first, then after that we could do the finding the limit. So first thing, we want to get rid of the absolute value sign. So these two bars means absolute value, and the absolute value sign, it means it will keep the inside to be positive. So x minus 2, in order to keep this one positive, it will be x greater than 2. Then it's positive, absolute value will just give it as x minus 2. And when x is less than 2, we sub in a number less than 2, for example 1. 1 minus 2 give you negative 1. And the absolute value is looking for the distance from that point to the origin, so it should be positive. Then the x minus 2 give you negative, the distance will be opposite, negative x minus 2. Then we are going to write the original function like this. So function f of x, we give it a name, so x minus 2 divided by x minus 2. Then we are going to sub in when x is greater than 2, it will be x minus 2. X minus 2 divided by x minus 2 will give you just 1. Same thing divide, it will be just 1. When x less than 2, we sub in the x value is negative x minus 2. Then divide by x minus 2. So this one is a factor of the denominator. So numerator, denominator, they have the same factor. We can cancel out. Then we have negative 1. Then we have this function is splitted as greater than 2, less than 2. Then we are going to have limiting value. When x approaches from the right side greater than 2, it will give you 1. And from the left side, it will give a function f of x, it will give you negative 1. And the right side, left side, they are not equal, so it means the limit value when x approaches 2 doesn't exist. So doesn't exist, we could just doesn't exist. And in a short word, it's just DNE, doesn't exist. And we are going to graph it, and you will see it clearly what happens here. So we draw the xy axis here. Then at x equals 2, so f of x will give you a straight line at the function value is 1. And when x is less than 2, it will give you negative 1. And you will see the limit for the function f of x from the right side is approaches 1, from left side is approaches negative 1, and they are not equal. So that is illustrates when the limit is not doesn't exist. So if they are equal, then it exists. And also at this point, you are going to see the function f at 2 doesn't exist too. We don't have the solid dot. We have two open dot. The open dot represent we don't include the x equals 2. So x equals 2 is not included. So f at 2 doesn't exist. So next example 3 is a find the limit of function f at x at x equals 1. This function is a piecewise function, so x less than 1, you have the function is y equals x minus 1, x equals 1, you have 1, greater than 1, we have 2 plus square root x minus 1. So we are going to sketch it, and for the first one is just a straight line. So I label the x, y axis and label the scale, and after that x equals 1, y equals 1 is a solid dot for this piecewise. And for the first one, x less than 1, we have x minus 1, then we use a mx plus b. So b is -1, it will be on the y-axis, the y-intercept is -1. Then we use a slope is 1 over 1, so that is a right one up 1. From the y-intercept, right one up 1, that is what? Another point. And remember that is less than 1, so it should be an open dot, doesn't include that point. Then we have 2 points, we can graph the straight line. So this is y equals x minus 1. This is for when x is less than 1. Then for the another one is 2 plus square root x minus 1. So when x equals 1, we sub in, it will be 2, but doesn't include that one, so we could create a table of values. So x equals 1 sub in is square root 0 is 2, then next number we want to pick x equals 2. So sub in 2 minus 1 is 1, square root 1 give you 1, 2 plus 1 give you 3. So x equals 2, y equals 3. Then the next number we want to do the 5. 5 sub in 5 minus 1 is 4, square root 4 is 2, 2 plus 2 is 4. So we have 5, 4. Another point, okay? Then this is 2 plus square root x minus 1. So how did I graph it? I create a table of values. So x equals 1, 2, 5. We sub in, we have the y value is 2, 3, and 4. So from this graph, we are going to see how can we find the limiting value of function f of x at x equals 1. So we are going to write limiting value x approaches 2 from the right side. So from the right side, we are going to see it is approaches to 2. And we are going to see limiting value when x approaches 2 from the left side. So from the left side approaches 1, sorry. That is not approaches 2, but approaches 1. Approach 1 from the right side. Approaches 1 from the left side, that is 0. And you will see that the right side, left side not equal, then the limit at 1 doesn't exist. So we are going to write is not equal the right side limit doesn't equal to the left side limit, so limit x approaches 1 doesn't exist. And we just want to go beyond that. Another one is function f at 1 equals what? Function f at 1 is our solid dot on the graph, so it is 1. So although the limiting value of the function f of x at x equals 1 doesn't exist, but function f at x, the value of the function f of x at x equals 1 exists. It equals to 1. The solid dot means that is the value of the function. Open dot, it means doesn't exist at that point. Okay, so that is example 3, and we are going to see the next example. Our next example is a graph is given. This is a piecewise function. We call this is a piecewise function because they are in each interval it is a different expression for that function. Okay. So this is y equals h at x. X belongs all real numbers, so there's no restrictions for x. And we are going to just read all this from the graph. So question A, it asks you limiting value when approaches from the left side to -1. So left side to -1, we are going to see it equals +1. And question B, from the right side to -1, right side to -1 is equals to -2. And the question C, limiting value, because the left side, the right side doesn't equal, so it doesn't exist. So we are going to write because left side h at x doesn't equal to the right side limit at -1, so it doesn't exist. So the limiting value doesn't exist. Then question D, the value of the function h at x, h at -1 is a solid dot, so h at -1 equals +1. Then question E, limiting value when x approaches 3 from the left side. Smaller number to that one give you 2. And question F, from the right side is 3. Question G, doesn't exist. It's same reason because the left side, right side doesn't equal 2, doesn't equal to 3. And question H, h at 3, the solid dot represents the value of the function at that point. So it is 2. So this is an example that show you how you can read from the graph the left side, then 1 minus means from the number that is smaller than -1. Read it from the left side. So in summary is the limiting value of the limit of function f of x when x approaches a equals L if and only if the left side limit equals right side limit equals a value. That value is a limit at that point. So in the learning goal for this lesson is you need to know how to find the left side limit, right side limit, and if they are equal, then you find the limit of the function at that point from algebraically or from the graph. So from algebraically is, if it's possible, you can sub in x equals a. If the function exists, then the value exists, then the limit equals the value of the function at that point. And if not, we are going to learn in future how we are going to manipulate the expression to get rid of the denominator equals 0. If you could get rid of the denominator equals 0, the expression is valid when you sub in the x equals a, then you don't have to do the left side, right side. You can just direct substitution to find the limit of the function. Thanks for watching.